So hello there. My name is Mike Sperber. Bene is probably going to be here pretty soon, but he's having technical issues. So I'm just going to start our talk. So Bene comes from a background of domain-driven design, and I come from a background of functional programming. And there's Bene, and you can start right there. Oh, we can't hear you yet? Is that what you're saying? Okay. So Bene, Bene, until a short while ago, was CTO of BLUME2000, which has an online offering of lots of flowers that you can buy, and introduced their a domain-driven design-based architecture with self-contained systems, and you can see that. Here. So there's several different systems that are all based sort of on similar architectural principles and domain-driven design. And so that was the starting point for our collaboration. So in domain-driven design, the things that we're going to talk about today is we'll talk about validation, specifically something that you want to do in the outer layers of a hexagonal architecture. We want to talk about the separation of business logic in the domain layer and the outer layer of an hexagonal architecture, and generally about the relationship between the ubiquitous language and domain-driven design and types. So this was Bene's part, really. So I come from a background of functional programming, which has evolved largely independently from domain-driven design. And the most important aspect of functional programming is pervasive immutability. So in your typical functional architecture, you have only value objects. That means you only have pure functions operating on those value objects. Functional programming originally started with the idea that functions are also objects, and so everything is data in your typical functional program, and so we'll clarify what that means for domain-driven design later. All of these things combined mean that you can have higher level abstractions than are practical in object-oriented programming, and one of the things that we typically do is we do domain modeling with the help of combinator models, which are one form of these higher level abstractions. And we support all of these things with specific functional programming languages. So for example, with generic function types, that's going to be important later, so that you have a language for talking about the signatures of functions. Typically, your functional programming language will come with a library of immutable data structures to support this pervasive immutability that I was talking about earlier. And you have unrestricted abstraction to support these abstract domain models that I mentioned on the previous slides. And today we really want to talk about introducing some of these principles into the domain architecture at BLUME2000, which is all based on the Kotlin programming language. And Kotlin, well, you probably know it's primarily an object-oriented language, but it also gives us some of the features that are typical for functional programming. So most importantly, Kotlin has generic function types, so you can talk about the types of functions independently. You can have pure functions. Of course, you can actually implement that concept that everything is data. You can have higher level abstractions, and you can also do pretty good combinator models in Kotlin, even though that will not be the focus of the talk today. So I'll start with talking about validation in the outer layers, or maybe just talk about validation in general. And I first want to start with a simpler idea, namely with that of optional values. So here's a function, I call it safe divide, that is just supposed to divide one number by another. And this is something that can go wrong if the divisor is 0. Of course, you can't divide x by y. And well, you can represent the fact that this function can go wrong in various different ways. One way to do it would be to raise an exception. But a better way to do it, or what we would typically do in functional programming, is raise that to the data level. You heard me mention saying that everything is data. And so here we introduce a special class called option. This corresponds to the optional class that you might have seen in Java. And an option thing that has an a type parameter that you see here. It's just something that might contain a result, or it might not contain a result if the operation that you were performing just didn't yield one. So in this case, you say, well, safe divide is going to return an option of int, so it might return an int, or it just might return nothing. And these are the two choices that you see there for the option interface that you see up there. Now, option is just a part of the arrow library, which just provides some functional programming facilities in Kotlin, which is something that we've been using throughout our project. So, Bene, you got audio now?
I think so. Do I have
yes,
audio?
I can hear you. So
oh,
now
you can hear me.
You
Great.
can take over finally.
Yeah. Hello, everybody. I think I had audio before, but we didn't notice because the mic unmuted itself or something. So I was only muted in the backstage. Never mind. Okay, yeah, validation. So why are we actually talking about validation here? And this is because, so we started with domain-driven design, right? So we want to integrate domain-driven design, make better domain-driven design by using functional programming. And why is validation important? This is a question that obviously comes to the mind. And I think one of the key aspects of domain-driven design, and it's the same thing that Eric Evans here states, is that that you want to ensure that you have valid data in your domain, right? So validation is a huge part of domain-driven design, and not only regarding to the outer layers, right? So to validate like an HTTP or JSON entity or whatever before you put it into the system, but you don't want to have invalid data in your domain at all. Or if you do have invalid data, you want to know this state of this invalid data so that you can handle that. So this is actually very, very important not to do this. I think the small example also has shown it very good. That's yeah, we can make a better one. Thank you, Mike. Right. So we have on the slide here. So doing that by using exceptions doesn't really help us knowing this states in our domain, because an exception is not a state, right? So an exception is an exception, and we need to handle that one, but we cannot combine it. We cannot we cannot react to it in a programmatic way, because it always like intercepts in our code. And so that's why Martin Fowler also had the idea. I think this example of him was like a bad example, right? So he
That's right. He
was not not to do it like this. So don't be confused here. This is like the bad way, and he said, hey, please replace that by using validation classes, so that you can actually combine that and move further on that. So what does it mean for object-oriented programming languages? So you probably know Spring or Spring Boot, and this is also the way we did it at BLUME2000 or with Hibernate validation framework. You always have these annotations, and the annotations have actually, it's like a hidden DSL with a hidden programming language of sorts, where we define the states you want to allow and disallow. But you then need to have a validator class, which then actually validates the created object after it has been created. So it's kind of weird, because going to the problems, it's very unclear. So you can create an invalid object. So you actually have an invalid object in your system then, and then you afterwards need to validate it and hopefully you do that all the time, so that you can then move on correctly in your domain code. But if you don't do this validation, then you have the problem of having invalid types or invalid states in your domain, and you are not, unclear of them. And also the control flow, when does the validation happen, or which validation happens when, it's very unclear. The DSL part, I already mentioned that. You have a hard coupled dependency to some validation framework, which is kind of like hard to replace it with another library, for example, or with a non-library and doing it with the code itself. So there's a lot of problems going on here, and it's probably a good way to look at an idea on how to make this better by introducing functional programming.
That's so. I mean, I think what you said, Beno, was just a long-winded way of saying, this is like creating an object and then validating it is just like the grandmother letting the wolf in through the door before validating that it's Red Riding Hood, right? And so that's what I think the fundamental problem is. Don't create objects that are invalid. And my friend and fellow functional programmer Ron Minsky's once coined the phrase "make illegal states unrepresentable," which amounts to saying that, well, don't create objects that are invalid. Make it, if possible, make it impossible to create invalid objects. And the way to do that is, again, to use an idea that's similar to the option data type that I showed earlier. And this idea is a little bit more elaborated. So we are using a validated data type. So for example, if we wanted to create a position object, like the position class that you saw in Bena's example earlier, you might create a function called off that creates that object. You pass it the values for all of these attributes, and it doesn't return directly a position object. Instead, it returns a validated object. And that validated object, well, it might contain the position, but if the validation failed, it will return a list of objects that describe what the problems were. And so you can see that the validated class there has two cases. So it has one case that's invalid, in which case it only contains a description of the problems, of the error that it found. And only in the valid case do you actually get an A object. So that's really important, is that you don't create an object if it would be invalid. And so here's the implementation of that off function. So you validate the input. So I've just validated one input here, but you can imagine something more elaborate happening. And only in the case that the validation actually succeeded do you create a valid object and create a position object along with it. And in the other case, you do not create a position object, and instead you create the invalid case of the validated data type. So again, we lift this problem instead of moving that problem to the strange world of annotations in your program, or to control flow where you have to specify the place where validation happens, is you move that problem into data, and that's typical of functional programming. And so this has a number of advantages. It means that objects are always validated, right? So the validity is expressed in the type system. If you see a position object, you know it's valid. If you have multiple stages of validity, then you should probably have different types for them, and you could express it in the same way. This is completely standard Kotlin, and it's very idiomatic Kotlin also. It becomes convenient through functional abstractions, which we're not showing here because we're really interested in the architectural aspect. So, but map, the map method that you might know from the stream class in Java is available for validated. And these functional abstractions also give you composability if you have more elaborate validation pipelines. And most importantly, these are all standard idioms and abstractions in functional programming. So you don't have to learn a whole new annotation DSL in order to use annotation. You can just use concepts that you know from other places in functional programming. Back to you, Beta.
Yeah, thank you, Mike. So now we have taken a look on how to validate in domain-driven design with functional programming to enhance the concept of our domain, right? So we actually, I found it you can actually now represent the real sentence in your code, right? So if you have a business process that either returns, okay, either is a different thingy there, but we talked about validated, but so you have either an error or the real object. So why don't say it that this is either an object or so the successful state or the failed state. And what we want to do with it, or we want to take it even further now, right? So this is only validation. And now one part of domain-driven design is, for me, is also to have the ability to really describe your business logic in your domain without having the dependency to incoming adapters or outgoing adapters, right? Without the dependency of knowing this is HTML or HTTP REST and this is like a MongoDB. So you really want to describe what the case is, and you want to fully describe it. Often we see that the stuff is going to be explained in the application service by the order of which the adapters are called, right? And there's the logic. If it's this, then call this adapter, and if it's that, call that adapter. So you have a control flow there, and this control flow really describes what is the business logic, right? So part of the business logic is the control flow, the order of which you do things and when you do stuff. And this business logic is really hard to encode in the domain without using functional ideas, I'd say. So there are functional ideas which help you to make that happen easier. So here you can see like some kind of orchestration here. really basic example. But let's say you want to publish multiple products, and then you first need to create an image, and you need to get an image from somewhere else, and you need to get a price from somewhere else. Then you can create the product, which you can then publish, right? So this is a business process you can imagine, right? So it could be other things like checking if the credit is valid or whatever, and this is also like stating a certain order. Maybe you can create the image, the price before you create the image, right? So there's a dependency here, and this is represented by code here in this example. And I think with using functional programming, you can really make this better. So I think the next slide, Mike, is So if you look at the hexagonal architecture, you want to encapsulate this idea of the process in your core application, in your domain, right? So you want to say, this is my process, these are the steps, and first you need to do this step, and then you need to do the second step, and then third step, and then you want to have some kind of abstraction which tells you how to really execute the steps. So step A is maybe a REST call to another system, and step B is maybe like an access to a database. But you don't want to know that in your code. You want to fix that process and really state, this is the steps, and when I change the steps, I don't want to change any outer layers, right? Because the outer layers only say which step is doing what, and not in which order, and not when which step needs to be executed. And let's move on to the issues here. So I basically said all of that in what I've stated before, but you need to have like if you want to do that, you need to have like a domain language for workflows, right? So currently we often just do like an entity aggregate root with a value object, and then you look very much on objects and states, and not on the transition of states and on the workflow of states when you look into your domain. And if you want to do that, you really fast get the problem of needing to do dependency injection, right? Because a workflow has certain dependencies. No workflow is without dependencies. And then you have the problem of, well, but I don't want to inject my adapter into my domain, right? So because the domain needs to be free of adapters. And then the next problem is you have cross-cutting concerns, right? Like logging, profiling, concurrency issues you want to handle in a workflow, which makes it really hard to really have a domain representation for a workflow, which then gets executed in an independent way, right? And I think Mike now wants to tell us a little bit more on how functional programming will help us do that, right?
Well, here, first of all, is a code example, right, from the BLUME2000 code base, right, that shows that the cross-cutting concerns and the actual workflow are intertwined and connected. And these are the things that we want to separate, right? So you can here see, there's product-related code that does something, but then there's, it gets the system timing in order to do some profiling, and these things are mixed together. And that was the starting point for us wanting to keep these things separate. So the natural place, Bene mentioned that we really want to represent workflows abstractly. And I mentioned that in functional programming, we try to represent things as data. And so the natural place to put these things together is just to represent the workflows as value objects in the domain-driven design sense. And that will also then automatically result in us using types to express our ubiquitous language, where the workflow is actually a thing and not just something a function does. And we'll need to think about a dependency injection mechanism for that, which is probably going to look a bit different from the way that we're used to in object-oriented programming. So here's how you can do that, representing workflows as value objects. So what we have is an interface called publish product process, which is the type for all of these workflows. And the A type parameter that you see here is the result that comes out of a workflow. So typically a workflow is going to have some sort of payload that comes out of it. And you can see that it has three different operations: get product image, get product price, and publish product. These are the exact same operations that you saw in Bene's example beforehand. And you can see here that, well, get product image and get product price accept a draft object. That's pretty much just a description of the product and some ID that comes along with it. And get product image will presumably extract some kind of image from the internet, from some database, from some camera, something like that. Get product price might invoke a pricing engine, but all of these things are not mentioned here. These would be, we're trying to separate the logic of the workflow from the actual implementation of these operations. Now, and when you're done, of course, so when you have the image and then you have the price, you can use that and the draft product to create a published object that you can feed to the published product operation. Now you notice that all of these three operations have a next step attribute, and that next step just tells you what happens with the result of that step in the process. So for example, the first one where it says next step, it accepts the product image, which is the image that was retrieved from the database or something. And then it results in the process that happens after the image has been retrieved. So in a way, this next step parameter is something like a callback. So if you've seen Node.js systems, for example, then you always specify a callback to be called when some operation has completed. In functional programming, we call that a continuation. Now, down at the bottom, you see the yield operation, and that's something that you need to use when you're done with the workflow in order to return the payload. So there you provide the result as an attribute to the yield thing. Now, looking at this is now a value representation of your workflow. So that's great, but you can imagine that it's pretty cumbersome to produce these objects, right? Because you need to always invoke the constructors, create continuations, and that gets, you get into a lot of curly braces and so on. So, but fortunately, Kotlin has something that you can usually find if you look in the documentation under DSLs. So what you can do is you can write a function like this one, publish product process, and it accepts a function that you can provide by just putting one pair of curly braces around it. So you can see that here. And that gets turned into, that is essentially a Lambda expression here in Kotlin. And you can see here that this publish product process function will produce this publish product process or object, the workflow description for you, even though the notation is exactly identical to the straight line Kotlin code that Bene showed you earlier. And the trick to this, there's a kind of technical trick, but which is very general in Kotlin, which is that you can write in front of a function, you can write the keyword suspend, and what it will do is it will make the compiler transform the body of your function in such a way that it will insert all of these continuations that we need in order to create our workflow. And in functional programming, we call this workflow, this way of organizing workflows, we call that monad. And so really what Kotlin provides, it provides you with a special way to have monadic syntax. And so that gives us a convenient notation for workflows. Of course, we still need to do dependency injection, and that takes the form of a function like the run function that you see here, where you feed in a process object, a workflow description, and you get back, this is the either data type that Bene mentioned earlier. It produces either, well, it might be that there's an error, right? Retrieving an image or price or something might go wrong when doing any of those steps. So in that case, it's going to produce an error message in the form of a published product error object, or it will produce the final result A. And in the process of producing that final result, it will execute all the process steps. So this is essentially an interpreter for our workflow, and it provides the connection between the workflow description and the actual.
Mike, can you step back a second? I want to add some. I want to add something. So what I found really, so I understood that here very well when I looked at this when, right? When, and then you have is this, is that, then do the order of this is statements doesn't really matter, right? So in our case, it is for readability. It's like first image price and so on, but it doesn't matter at all. So this is what I mentioned before, that you can really abstract the way the process works from how it's getting parsed and then used, right? Yeah. So most of you have already noticed that, but I found that very interesting and regarding the code, right?
Yes. And I would argue that this really is a truly object-oriented approach to things, right? We represent our workflow as an object. And this way, we abstract over control flow issues. And in particular, I mean, we can use this dependency injection that you saw here. We could just insert profiling code here with no problems whatsoever. But we could also represent cross-cutting concerns such as concurrency, which are always kind of thorny in these types of systems. And it completely separates the domain logic from the adapter. Dependency injection is slightly different in that you don't just don't just provide an object implementing an interface. You really need to provide an interpreter function in order to specify how the control flow is handled. But from there on, once you've done that, things work just fine with standard object-oriented dependency injection frameworks. So we've used it with Spring Boot in our example project, but it's probably going to work with just about any of those frameworks. So, Benny, you want to express this one?
Yes. So I first come. So I really like. So I learned DDD a few years ago, and I also was very keen on learning functional programming. And at some point there was this book from Blashin, right? He was the first one to have published something like functional domain-driven design with F#. So it was kind of an outsider language, but this was the first time I really felt, wow, these concepts they really match. So it's a real good combination. You can really enhance your domain-driven design code and your architecture of your project when using these functional aspects. You don't even need to do like the pure full functional way or whatever. So really just using some aspects like we've shown you, like the validation or the abstraction of the workflow, using it for a little bit better dependency injection, it really helps to increase the idea of having a pure domain representing the domain business logic. And then there is also other stuff which we haven't shown you yet or now to don't overthrow the time. Is using immutability is obviously something that's very interesting as well, because you have immutability in your real business processes. So there is a formula or form for a loan or whatever, and you cannot change it afterwards. So you should have immutability in your logic as well. And there's stuff like combining certain processes or combining certain steps or whatever. It's also something that's really nice in functional programming, which can help you for domain-driven design. So I really think it's a perfect match here. Yeah. And now if you look at Kotlin, so you could do it with Haskell or with Scala, for example. You could even do it with Java. But I think so. From Mike and I tried a few of these languages out for different approaches, and we really wanted to make to help the object-oriented people and the functional people to get along or to move closer to another, and not just have all this fight all the time. We don't like this fight because it's unnecessary. It's not creating any value. And Kotlin was a language which we felt was a nice introduction for the object-oriented people to really have a low entry point, and for the functional-oriented people, it was like good enough to represent these functional ideas, right? So Scala is obviously a lot better when you look at functional ideas and functional possibilities, but it's a way further step for people coming from Java or from object-oriented programming. So data classes are obviously very nice to have like fast immutability. The function types are very nice, and also we showed you this suspend syntax for monadic syntax. It's a nice way to have this these low level also. So some parts of this functional ideas into your code. Yeah.
That's right. But coming from functional programming, I'm still missing some ideas, and so I would be amiss if I didn't mention those. So it would be really nice if Kotlin offered a standard set of immutable collections as part of its standard library. That would make it a lot easier to also interoperate between different sort of functional parts of a program. The Kotlin type system still has some restrictions. So, for example, we can define individual monads, these workflows that I showed you. But the concept of a monad is difficult to express in the Kotlin type system as an interface, which is something that we'd like to do. And so, and there's another nit in that in order to design the DSLs for these workflows, it would be helpful to be able to compose them with some composable overloading mechanism, as we have in Scala and Haskell, for example. So there's still some ways to go for Kotlin to offer the full power of functional programming, but this already gets us sufficient benefits over Java to make it worthwhile. So in conclusion, really, I think hopefully we've shown you that the functional programming principles, we've just shown you 2 of them, they complement domain-driven design pretty straightforwardly, and you can use any domain-driven design project and use them to implement those ideas better. Specifically, Kotlin actually does work a little better than Java doing this, because it just has better support for functional programming. And these ideas, immutability, purity, types, and monads, are something that's eminently doable and practical in Kotlin. In particular, I was really surprised that this suspend feature allows us to get this nice monadic syntax, which I wasn't aware of before I dived a little deeper into Kotlin. On the other hand,
it took a while, right?
It took a while. Yeah, it took a while. So anyway, but you can still get a little bit more mileage out of functional programming if you use actual functional languages. So this is an ongoing project that Ben and I have. I think the next step that we have is we need to talk more about sort of the didactics of monads. We always find that there's mismatches in our perception of what goes on. So we'll look for blog posts in the near future. Probably have 1 or 2 magazine articles in the pipeline and more talks. We want to make, so the monads that I showed you, we get this very convenient notation, but they're a little cumbersome to implement, and we think we can make that more convenient. We want to talk a little bit more about combinator libraries, and also kind of as a side project out of this, you remember this idea from functional programming that everything is data, or if you express this in terms of object-oriented programming, you would say that everything is object-oriented. And it was somewhat to my dismay that we found that Spring Boot is not particularly object-oriented. There's a lot of objects you don't get your hands on when it comes to dependency injection and dependency management. And I think it would be better if it were actually object-oriented. So that's something that we plan to work on, hopefully next year. If you're interested in this stuff, as I mentioned, ongoing work, there's a GitLab repository that is linked here that contains our ongoing state of the project. And that's all we have to say for today. Are there
Thank
any
you.
questions?
Thank you very much, Mike and Bene, for this very insightful talk. Yeah, let's see what we have in our Q&A. There is one very short question. Why option int in angle brackets versus int?
Should I take that one, Bene?
Yeah, sure. Go ahead.
So if you return, well, I mean, as I mentioned, right, save divide. Well, maybe I can find that slide, right? It's at the very beginning. So here it is, right? So division is undefined if you're dividing by 0, right? And so there's no number that you can return that would correctly state that it's x divided by y, right? And in this case, really, there's no int you could return that. So ideally, when you call save divide, you would like to know that the division failed, right? And if you're just returning an int, you think, well, there's a number. The type says I'm getting a number back, and therefore that must be the result of dividing x by y, when in fact it isn't. And therefore you need to add an extra value or an extra something to your int to denote the fact that it failed. And that's exactly what option does, is it adds one special value to your type that just says that there isn't a result. There's lots of situations where you can just imagine using the int type. I mean, if you're finding the index of some value in an array, you might think of using an int and just returning like -1 or something. But then again, you're not reflecting the fact that your function might fail in the types. And so your types are not as expressive as they could be. And I think, Bene, that's what we try to do in our domain modeling and domain-driven design. We try to make our domain model very expressive. And that means, and in a type language, we try to reflect the domain model in the types. And the more we can express about our domain understanding of the types, the better. And so int is not enough. We really need to express the fact that it might save divide or some other function might not return.
One could even argue that an option is not good as well, because you don't know what was the actual problem, right? You could even say you would have to like an either and some kind of error type and the int to be able to know which type of error it was.
Yeah, but often you have just one way it could have gone wrong. So in this case, there's only one way this is going to go wrong.
So Richard stated in the chat that there's an included optional in Kotlin. That's true. So you could add you could use int ? Which is in Kotlin not null. So it's not like in Java. It's not the null, but it's an option. But we were not using that standard thing of Kotlin because there aren't as many implemented higher functions on that one yet.
Yeah.
So we are using the arrow option. Yeah. The combination is difficult. Yeah.
Yeah. So it's difficult to get composability from the nullable types in Kotlin.
So that's why we are using the optional part from arrow. Yeah.
Okay. Thank you. Let's jump to the second question. How do you separate side effects from the business logic?
Oh, that's a good one.
Who's going to take that?
Mike is looking for the slide. No,
I'm looking for the slide. Yeah. So we did it, right? So the way that you do that is, well, here's the description of the workflow, right? And this has you construct that process without invoking any side effects at all, right? This is just an object, and you can use functional abstractions, and it's immutable. And so you can use regular functional abstractions to abstract over it. Now, notice one thing that I didn't mention in the talk is that now these workflows get a special type as well. This gets reflected in the domain language, and it gets reflected in the types as well, because everywhere you have this process, you see that word publish product process, right? So that marks that, oh, here's a part of the program that's concerned with publishing products. And only when you call this run function do any actual side effects get invoked, right? So that's where the transition happens from the pure world of constructing the workflow to the side effecting world of actually running the thing, which typically happens in an adapter in your hexagonal architecture. Now, I don't know if that was your question, but so Kotlin does not enforce this, right? It does not enforce this separation. So in principle, you could construct one of these things and the callback do a side effect. You shouldn't do that, but you could, right? So Kotlin doesn't have the language facilities to separate that, and that's something I'd like. So there are functional languages such as Haskell, which actually keep you from doing the compiler and the type system keep you from doing that, and forces you to keep these two worlds apart. But we can use the same ideas. We just don't get as much help from the compiler actually enforcing that separation.
Okay. Another one, how hard is it to explain functional behaviors to teams getting used to OOP DDD?
Well, that's a good one for me, right?
Sure.
So we did that at BLUME2000 when we introduced these ideas into our code base and building a new e-commerce system, and it was so we took the help of Mike to explain them the functional ideas. So we had some kind of multiple workshops doing a little bit of hacking with Racket, like it's a language for teaching. You could actually use it for real stuff as well, but it's mostly used for teaching functional ideas. And I think it's the hard part is really to make the teams understand the ideas behind why you are doing that. So because most of the time you say, well, I can do it like this as well. Yeah, you could. So there are obviously like a lot of ways to do stuff, but why would you do it in such a way? Why is it better, or why does it help you more? And once you answer this question for them, or they get the hang of it, why you are doing it, then it's pretty easy, I guess, to explain them, because then the motivation is there to learn that. Yeah.
Maybe I could take a different take on this question, right?
Sure.
Which is that so I've done so I have a long history of teaching functional programming. This is something functional programming as a pervasive discipline where you do everything in a functional way. That's something that's easier to learn than object-oriented programming. And I've actually in a past life I was at the university and we did research into that. So that's something that's easy to learn. What we're unsure about. So if your team then decides, well, I'm just going to full on do functional programming, I think that's a route that if you can make that decision, that's something that's easier to do than what we're trying to do, which is to take an existing OO project and finding the sweet spots where object-oriented programming can interoperate with the object-oriented parts in such ways that it can get you benefits, right? And so this this was the starting point of this project, and we're still. So I don't know that we know the answer to that question, right? How easy it is to figure that out, but we'd love to get your feedback if you try any of these concepts out in your projects.
Thank you for your answers. We have one last question. Do you implement entities as technically immutable?
Depends on who you ask out of us two, right? So Bene would
Yeah,
probably
and
say
on
yes.
the business, yeah, yes.
And I would
Yeah.
say no. So, as I said, when you do full and functional programming, you do pervasive immutability. So entities, when you have what you would think of as a state change to your entity, you just return a new one. You return a new object.
Yeah. So we would do it like this as well. Yeah.
Yeah, you should do that too.
Okay, then I guess we are done with the questions from the audience. So thank you very much again, Mike and Bene. And please, everybody, don't forget to give feedback over Hopin. Yeah, and I hope you have a good day here at SATConf. So take care.
Yep.
Bye.
Thank you guys. Bye-bye.